This is solving for the pH of a weak acid solution. Example 1. Let's determine the pH of a 0.50 molar HF solution. The Ka is 7.2 times 10 raised to the negative 4, meaning this is considered a weak acid. I am showing the autoionization of water to show that the contribution to H+ from water can be ignored. I have discussed the ice table in an earlier video and will refer you to that video for an explanation of the ice table. Here, we can insert the equilibrium concentration terms into the Ka expression. And because HF is a weak acid, we can approximate that the minus X term in the denominator can be ignored. Solving for X, and thus the concentration of H+ at equilibrium, gives us 1.9 times 10 raised to the minus 2 molar. Let's check the percent dissociation before solving for the pH. The percent dissociation is the amount of H+ that dissociates as a function of the initial acid concentration. The percent here is 3.8%. The approximation is acceptable because the percent dissociation is less than 5%. This is generally accepted. The pH is the negative log of 1.9 times 10 raised to the minus 2, which is a pH of 1.72. Thank you for watching.